This week, there are several steps to your project assignment. I think that if you just take it step by step, hopefully it shouldn't be too big of an issue, especially if you've already gone through the book chapters. So the first thing you're going to do is calculate the confidence interval. And for most of you, I think everyone has a sample of at least 100, and maybe one person has a sample size of like 102 or something. So everybody would be using the formula for a large sample size, which is n of greater than or equal to 100. So before you start plugging numbers in and looking at the formula and being concerned about it, get the numbers that you need and have them handy so you can just plug them into your formula. And at that point, you're just doing very basic functions, and you can use a calculator to even do those. So you need the mean of your dependent variable. You need the z-score, which you will find using the table in your book. You need the alpha level, the standard deviation, and the sample size. And once you have those numbers, you'll be able to calculate the confidence interval. So I'm going to share my screen so I can go into SPSS, because SPSS is where you will obtain the mean and the standard deviation for your variable. You already have the other pieces of information, but I'll talk about that as I do my share screen and go through the SPSS stuff. Okay, so let's see. I think this is it, I hope. Okay, good. So we are in the data view, and keep in mind, I have 55 observations in my data. I'm just gonna keep my data at 55, and I'm gonna pretend like I have 100 because I'm using the formula for large sample size and things like that. So know that if you notice that my sample size is only 55, just pretend like it's 100, it's not an issue. For at least for illustrative purposes. For you guys, it is an issue because it can affect your output. So that's why I had to use 100 observations, because without it, what the information you would get could possibly be invalid without, it violates statistical assumptions. Let me just put it that way. So I allowed myself to violate statistical assumptions because I'm just using my own data, which is actually fake, to illustrate things for you guys. If I was actually running analysis and the numbers were meaningful, I definitely would not do things, or I would do my best to avoid violating statistical assumptions. So the first thing you want to do is get the mean of your dependent variable, which you're going to go to Analyze, Descriptives, Frequencies. Your three variables are probably going to be over here. So you're going to find your dependent variable. Remember, like week 1, I said it's imperative that you understand independent versus dependent variables and levels of measure. And I think by this point you should see that this information it's relevant throughout the entire course. So hopefully you know what your dependent variable is. Mine is attitudes toward capital punishment. So I'm going to move it over. I'm going to click on statistics. The mean is already checked. I don't think that that's the default. I think the default, and same with standard deviation, I think the default is that nothing is checked. So this is what you would get. Go and check the mean and check the standard deviation. And now remember, when we learned about measures of central tendency, and I mentioned this at the time, mean and standard deviation really can only be calculated for interval ratio level variables, or what we call continuous variables. My measure of death penalty attitudes is ordinal. It's a scale of 1 to 5. So technically I'm doing something I am not supposed to be doing, and you guys will be too. I mentioned this before. Trying to have you guys or require you guys to come up with an interval ratio level dependent variable within 1 week and getting 100 observations, I think you could have done it, but it seemed to me like it was asking a lot. So I gave you some flexibility and said, go ahead and just, if you're asking people about their attitudes, or if, you're measuring something that is ordinal level, that was an okay thing to do. You can still, for purposes of this class, go ahead with the mean and standard deviation. Technically, like I said, you're not supposed to be doing this, and you should know you're not supposed to be doing this, but for you to show me and demonstrate your knowledge of the course material, it's completely fine. So check means, check standard deviation, click continue, click OK, and now we have that information, although your valid sample size should be 100 or possibly more. So we know, I lost it now. What the heck just happened? That was weird. No, I don't want to save these. Okay, I'll just rerun it. Analyze descriptive frequencies. Okay, there we go. So we know that the mean out of 5, it's a 1 to 5 scale of support for capital punishment, with higher values meaning more support. So 2.84 means that people are moderate, slightly opposed in my sample, but remember my data are fake. Standard deviation is 1.244, and you see this information. This is the only information you need for this week from this. You don't need to save it. You can if you want. So you're going to have that information, and now you're going to calculate the confidence interval. Get out of this. No, I'm not going to save it. Okay, so you now you need to obtain information on the Z-score. Get back out of here for a minute. Okay, so you need to obtain information on the Z-score. Use the table in the book. So using the table in the book, my Z-score is going to be 1.96. Your alpha level, I gave this to you. Well, you have to do one basic subtraction. By telling you to calculate the 95% confidence interval, then all you do is take 100% minus 95%, because the alpha level is the likelihood that you could possibly be making an error. So we want to know with 95% certainty that we're not making an error, which means that there is a 5% certainty that or a 5% possibility that we are making an error. So the alpha level is just 100%, which is we know we're right, which is never ever going to be the case in research, because by its nature, research is probabilistic. So we're going to take 100% minus whatever the confidence interval is. And in this case, for all of you, it's 95%. That gives you 5%. So the alpha level is 0.05, because we don't work with percent. We work with the decimal. So 5% is 0.05. So the alpha level is 0.05. The standard deviation I had from the SPSS output, which is 1.244. My sample size, I'm using 100, even though technically my sample size is 55. I said it was 100. So then you're going to take the formula for a confidence interval, which is the mean plus or minus the critical value of Z times standard deviation over the square root of your sample size minus 1. And that formula is in the book. So I know it was probably an earful for you to hear that, and that's fine. So you can see I worked out the arithmetic, and I'll show it to you in a second. And this is what I want from you. If you want to show it to me step by step on your phone because you're using a calculator on your phone, that's fine. If you want to show it to me on a calculator step by step, that's fine. If you want to handwrite it out, as long as I can see it, that's fine. Like I would recommend maybe using a dark pen or a Sharpie or a marker or even a crayon, just something I can see. If you want to have it typed out already and printed, or you want to share your screen and you have it typed out or something like that, I'm totally flexible with how you present the information to me as long as it's presented. So for me, my mean, which was 2.84 plus or minus the critical value of Z, which is 1.96, times the standard deviation, which was 1.244, over the square root of my sample size minus 1. My sample size is 100. 100 minus 1 is 99, so it would be the square root of 99. So that was how I laid out my formula, and then I'll show it to you using the numbers here. And I'll hold it up and pause for 5 or 10 seconds so you can actually take a look at it. And then I ended up with 2.84 plus or minus 0.245. So the first thing I did was subtracted 2.84 minus 0.245. And that's where I got the lower limit of my confidence interval. And then my upper limit was 2.84, which is the mean, plus that number that came from the right side of the formula. And that's where I had my upper limit. So you have the mean plus or minus that stuff on the right side of the formula. And that's what gives you the lower bound and the upper bound, or the lower limit and upper limit of the confidence interval. So wait, let me see. Hopefully, I don't know if you can see this. Yeah, hopefully you can see that. So you can see how I worked it out. I used a black pen, so if you have a hard time reading it, then please make sure that you use a Sharpie or something, because if you're having a hard time reading my numbers, hopefully you at least understand the gist of it and you can see that, how I followed the formula in the book. I'm going to need to see your numbers to make sure that you actually did the formula, that you carried it out correctly. So if you're having a hard time reading this, please make sure that you use something that I can definitely see if you choose to hold it up the way I just did. So after you do the confidence interval, you are going to choose, I believe that's what the assignment says, yes, you're going to choose one of your independent variables, and you're going to write a null and an alternative hypothesis. You should know now that the null hypothesis is a hypothesis of no relationship. So my independent variable that I chose was political ideology. And so my null hypothesis, and please state this using your variables, and I say this in the assignment description, do not just say there's no relationship between the variables. Use your own variables and speak substantively. So in my case, I would say there is no relationship between political ideology and death penalty attitudes. If you say something along those lines, there is no difference between the mean of death penalty attitudes based on respondents' political ideologies. That's fine, as long as your overall point is that there is no relationship between your independent and dependent variable. My alternative or my research hypothesis would be, what do I actually predict is the relationship would be between the independent and dependent variable? And my research hypothesis here is that more liberal people will be more opposed to capital punishment, while more conservative people will be more supportive of capital punishment. So make sure that you state the null and the alternative hypotheses, and do so in the context of your variables. Don't just say there's going to be a relationship between my variables, or there won't be. Tell me what your variables are, and then also how you expect your independent variable to affect your dependent variable. Okay, so I'm going to go back to SPSS, and at this point you need to recode. So to recode, you are recoding your dependent variable into two categories. You can do chi-square with categorical data. I have you do 2 by 2 just because I think it's easier to interpret. If you are really, really comfortable and confident with the material, and you don't want to, you prefer to leave your variables, I still need to see that you can do the recode, so at least carry out the recode. But if you're ambitious and want to try to interpret the chi-square using like a 3 by 2 table, or if you have a 4 by 2 measure or something like that, that's fine. But I would recommend that you simplify it. So we're going to recode. I'm sorry, you're actually not going to have a 2 by 2 table. You'll have whatever your independent variable is, however many categories that is. So for some of you, if you use a 3 category variable, that's fine. If you have a 5 category Likert scale, that's fine too. You do have to have a categorical independent variable though, so you can run the chi-square. Okay, so you're going to go to transform, recode into different variables. If you recode into the same variable, you are going to lose your original data. Don't do that. Do not ever, ever, ever do that. If you become a professional researcher, if you do research, you use SPSS in your career, no matter what anybody tells you, do not ever recode into the same variable. You will lose your data. So you want to recode into different variables. I am recoding attitudes toward capital punishment. Old and new values. You should ahead of time decide how you are going to recode. So my original scale was a 5. There were 5 response options. 1 was strongly opposed, 2 was opposed, 3 is neutral, 4 was support, and 5 is strongly support. So the way I decided to recode was into 2 categories. One category is just people who do not explicitly support capital punishment. And then my other category is people who do explicitly support capital punishment. So the old value is 1, which your old values are going to be the actual values on your survey. So my old values were 1, 2, 3, 4, and 5. 1 was strongly opposed to 5 is strongly support. My new value, I'm going to make that a 0. And I'm going to add. Now anything with a new value of 0 is going to be people who do not explicitly support capital punishment. So my old value of 1 meant that people strongly oppose capital punishment. So strongly opposed definitely means they don't support it. So my old value of 2 was people who are opposed to capital punishment. So again, people who are opposed are going to get a 0 because they don't explicitly support capital punishment, and that's what that new category of 0 means. So that's going to get a 0. Now 3 is neutral, and that was where I had to decide, what do I do with the 3s? Because I can do 1 and 2 are opposed and 4 and 5 are supportive, but what do I do with the 3s? And that was where I decided to say people who don't explicitly support. So people who are neutral, they did not explicitly support capital punishment, so I am also going to give them a value of 0. Now 4, these people support. They didn't strongly support, but they supported it. So their support was explicit. So 1s are people, my 0 category are people who do not explicitly support capital punishment. My 1 category are people who do explicitly support capital punishment. And then 5, people who strongly support it, definitely are explicit. So we have, if you look at the new values, there are 2 of them, 0s and 1s. We are going to, sorry, the mouse on this, okay. Click continue, and now we need the output variable name, which I am going to leave. You can see the variable name here. I am just going to put an R in front of that. It tells me it's a recoded variable. So RDP attitudes. You can rename this whatever you want. If you wanted to do DP attitudes REC for recode. If you wanted to do 2, I don't know if you can do numbers, but you could try 2 DP attitude for, it's the second one, and because it is a 2, that means it's recoded. Whatever works for you. That's just my own personal preference, is that I put the R in front of it to tell me it's recoded. And then the label, you just tell, just like in the code book, what is this variable? It is death penalty attitudes recoded into 2 categories. Change it, and now at this point it will let you click OK. And you can see, I don't need this output, it's just telling me that the recode happened. You can see right here that death penalty, there should be 0s and 1s. I want to get rid of those decimals, they annoy me. It's numeric 8. The values, actually it just added the code book, so if you wanted to, you could do 0. The label is people who do not explicitly support capital punishment. 1, people who explicitly support capital punishment. Okay. I'm not sure why it's doing that. It's fine. Okay. It is a nominal measure, and that's all fine. Okay, so you can now have an updated code book. The next thing I want to do is run a quick frequency on the recoded variable to make sure it's clean. So it should be death penalty attitudes recoded. Okay, and all I want to do is just make sure that there are just 0s and 1s. Yeah. People who do not explicitly support and 1s, it just, these are the 0s and these are the 1s. The code book didn't like my wording for some reason, so it just left it a 1, which is fine. So yeah, I can see that, yes, everyone fell into the 2 categories that I designated. That was what I wanted. So I know that I still have a clean data set. I'm going to save this before I forget. I don't need to save the output. Okay, so I now have a recoded dependent variable. So the last thing I need to do is run a chi-square. So to do that, I'm going to go to Analyze, Crosstab. I can run Crosstab. I'm sorry, Analyze Descriptive, then Crosstabs. Get that out of there. And now we are going to move my independent variable, which is political views, into the row, and the recoded dependent variable into the column. I'm going to click on statistics. None of this will be checked for you guys, so it's going to look like this. You're going to click chi-square. Because I have nominal, I'm going to click, I'm going to use this measure of association. You can also use lambda, and your book talks about the different measures of association and which one you use when. So that this is just a personal choice. It doesn't matter. Like I said, you can do this, and lambda. It's going to give you a measure of association, and they're not, if the association between the variables is strong, both of them are going to show you that. And if the association is weak, they're both should show you that. So substantively, it shouldn't make much of a difference. You're going to click continue. Then you're going to go into cells. Leave the observed checked. You're going to click row, column, total. And you're going to click continue, and then you're going to click OK. Okay, so the first thing you're interested in looking at, okay, that just shows you sample size, is the Pearson chi-square. And you're looking at the significance, and we're looking for a number less than 0.05. 0.02 is less than 0.05, so it tells me that my relationship between political ideology and attitudes toward capital punishment is a statistically significant relationship. So this is the only row that you're interested in, and it's the first thing you want to look at is the chi-square is the chi-square statistically significant? And it is. Now you can look up here, and in the illustrations in your book, you should be able to look at the chart to see, is it the way I expected it to be? Because chi-square doesn't tell you, is it the liberals or the conservatives that are more likely to support capital punishment? It doesn't give you the direction. So hypothetically, your hypothesis could be completely wrong. But it's not that the variables aren't related, it's that they're related in the opposite direction that you expected. It's rare, but it can happen. So you can't just say chi-square is significant, therefore my hypothesis is correct, because you don't know that yet. That's why you need the measures of association, and that's why you need to look at the chart. So you would need to look and say, okay, people who are very liberal explicitly support versus do not explicitly support. So so you can go through the chart, but you would do this for your own variables. The phi and Kramer's V, significant, which is not, it should be, and it tells you that the strength of the association is moderate. The closer to 1 you get, the stronger the association is. And it also tells you the direction. So it's positive, meaning that more conservative people are more likely to support capital punishment. So you're looking again at two things, the strength and the direction, and that's what the measures of association tell you. So it just tells you that, yes, my hypothesis is supported, and you would need to say that. Like in the assignment, it tells you, you need to talk about the null hypothesis and the alternative. So in this case, I would reject the null hypothesis of no relationship, and I would say that my hypothesis that people who are more conservative tend to be more supportive of capital punishment, that hypothesis is supported at least at the bivariate level, meaning when I'm just looking at the relationship between the independent and dependent variable, that relationship is supported. If your chi-square is not significant, normally you wouldn't even look at the measures of association, because if chi-square is not significant, then it becomes completely irrelevant. You wouldn't look at the measure of association. You don't care about the strength or the direction of the relationship, because it's not a significant relationship. For purposes of this class, if you get an or a non-significant chi-square, I still want you to go down and look at those, whatever measure of association you have, and I want you to talk about it and say, and usually if you have a non-significant chi-square, this number is going to be low. It'll be like 0.0 something or 0.1 something, and then you can just say, you know, it's not surprising that the measure of association is very weak. Like the relationship that really doesn't exist statistically anyway is a weak relationship. Very, very, very rarely, and it usually, there's an explanation for it that's pretty complex and way outside the scope of this class, but it's very unusual to have that this number would be high and not significant. Typically, non-significant relationships, this number will be low. Now, you might have a statistically significant chi-square, and this number still could be low. It could be a weak statistically significant relationship. So if you have a statistically significant chi-square and this is low, that's completely fine. I hope this helped. Let me know if you guys have questions about anything. No, we're not going to save that. Stop the share. All right. Let me know if you have questions about anything. I know that this week is a little bit more involved, but again, just take it step by step and you shouldn't have much trouble, especially if you've already gone through the material in the book. So I hope things are going great for you, and you know, we'll definitely continue to be in touch throughout this summer.